This is the OpenBridge Designer workflow, in which the creation of the physical model, the 3D physical model, becomes the centric part of our bridge process. We start, of course, with the 3D physical modeling, bringing the information from roadway, from survey, from mapping, all to our desktop. So there is no need to initiate with a white canvas. We just need to bring the information and use it as a reference to set up our bridge. Using MicroStation technology of reference files, we can quickly access all that and just define the location of our bridge, even including reality modeling meshes. So then we can really design our project in a true reality context. Next step will be, of course, to keep going with the physical model and start creating our bridge. So how many support lines do I need? Is a 2-span, 3-span bridge? Is there a skew angle on the supports? So just place the structure. Now, as you can see, we're modeling mostly in top view. Even though this is a 3D file, it makes easier for any user to start the process in what we call maybe a 2D environment, which is not. Actually, is the top view of a 3D file. Let's place this segmental bridge with many different methods. This could be, for example, balance cantilever, span by span, could be a steel bridge, could be a pre-stressed girder bridge, in which you can define your own sections. And then let's place this segmental bridge, for example. Then we have our bridge. What is the next step then? Continuing again with the creation of the physical model. As you can see, the 3D is happening already, following the alignment, following the profile of the roadway. So now let's place the supports. How many piers? What is the configuration of the piers you want to use? 2 columns, 3 columns, single pier. So these templates that you see on my screen, that could be also defined by the user. And let's place them. And do we need to tell it where it's supposed to go? No, they know that it needs to go just below the segment box and also reacting to the ground. Remember, we brought the survey information? Well, we tell them to go 2 meters, 3 meters, 6 feet, whatever units below the ground, and it's reacting to the ground conditions. So the columns, some of them will be taller, some of them will be shorter. Maybe I need to skew one of the piers. So we can adjust the stationing. So we can certainly do that without recreating the bridge, without doing any scripts or visual programming. This is an application designed for bridges. So it understands the elements that belong to the bridge. It understands that the beams go below the deck, that below the beams it should go the supports, but between the supports and the beam it should be the bearing supports, for example. So all that options are available to the user for start creating the bridge. Not only that, but after we define the locations, we can say that, oh, we need to change the structure. So how quickly we can react to change? One more time. We can just, this single pier maybe, replace it by a complete different structure. As we can user define that without creating a full 3D model, just using dialog boxes, we can just rearrange and create a new structure, change the pile configuration that I need, the materials that I need. So all of that through the use of dialog boxes, and rather than creating the 3D model per se, I just can modify the structure using that and reacting to it. So now it's going to be H piles, for example. So I can just react to change fairly quick on that part. So, and then my 3D model will be updated automatically, right? Or, as I said, switch to a complete different set of structures. Maybe this will be a 3-column pier. and then I have it. And always checking for that conditions how they are related to the ground, and then detect early that I may have run into problems, like right here, in which as changing the structure, the footings are exposed because of the ground conditions. So it's not enough to get an elevation, it's just to react to that ground conditions and say, well, I need to bury the footings a little bit more than I expected, just on that particular section of the ground because of the relief of the terrain. So do that, and that problem is solved. So that's how quickly react to change. But now my 3D physical model could go into more changes, even drastic changes, as maybe the roadway engineer using any application, any geometry application, in this case is using OpenBridge Designer, he can go and change the actual profile of the entire project. So as he's doing that in his own application, he may need to see where my bridge is located. So as my bridge is there, also with the reference file technology, he can say, well, let's do this 3D cut and see what do I have along my profile. And it happens to be that it detects the presence of a bridge, and it will be displayed along his profile. So that's where my bridge is located. And he knows now that if he changes the roadway profile, of course, he will be affecting the bridge. So nevertheless, he will just go and do the change in his own application. As I said, in this case, in OpenBridge Designer, and he will change the profile affecting my bridge, right? So it's the decision of the bridge engineer, as he's the owner of that structure, to decide if he needs to update the new bridge or just maybe come back to the highway engineer and just don't allow that modification. So as the bridge engineer goes into OpenBridge Designer and sees that modification, right? You see that? So that the geometry file has changed. Well, he said, let's update the bridge because we need to do it, and then we need to deal on what modifications brought up to my bridge design. So maybe I need to redesign the bridge, readjust some of the locations of the abutments, redesign the bridge per se. So a minor modification that could be interpreted as maybe a few centimeters or inches into the profile could really affect the structure. And as it is, it's affecting the structure. So now, as a bridge designer, I need to face with that changes, and also the roadway engineer needs to update his roadway as well. But then I don't need to redo the structure. We just reacting to changes. We adapt to changes very quick, coming from, in this case, from roadway. Not only that, changes could be affected as well by other reasons. For example, a utility line that it shows up into my project, and I need to modify my design. I need to move a pier. I need to skew the pier because actually that utility line is conflicting with my piles. So how do I know that? Not only by visual inspection, but as well by the included tool in OpenBridge Designer of clash detection, in which I can define the envelope or clearance measurement between, in this case, against my piles or my footings against the utility line, a drainage pipe, a sewer pipe, and the software will just scan the model and tells me the distance between this conflict. And then I just need to react to that. How can I react? Well, maybe call the utility engineer and said, you need to move your line. Or then I have to modify the foundation or even the location of that pier just to address that changes. But now again, this change is addressed here in the office rather than on the field. Well, let's keep going. Now, remember, on the workflow, the physical model is more or less done. Now I have to send it to Analytic. Do I need to create another model? No, I just connect, in this case, to OpenBridge and say, take my segmental bridge that was done as a physical model and make it into an analytical one. And that analytical one, it gets converted, it gets designed, right? It gets a structural check, as we call, so for dead loads, and I can confirm that more or less my structure uh, is working. I can just add the design to it. I can add the tendon layout, in this case of a segmental bridge, and make it part of this analytical model. Right? So now my bridge is working. Right? I can just, as analytical, generate all the analytical reports, moment diagram, shear diagrams, deflections, and all being displayed and create a true analytical report as well. But then, following the workflow, this information needs to be sent to the 3D model, to the physical model. So the analytical solution, through an automated process, sends all the information, all the pertaining information to the physical model. What kind of information we can see, for example? The tendon layout that I created in my analytical solution. But this tendon layout now is a solid element with properties. So it's not just a line. It recognizes that these elements are tendons, and it has properties that we can review, make it now a true beam model. Right? So this is the actual tendon layout in 3D that I just created through my analytical solution. And if I check its properties, I can see what tendon type it is, what the stressing forces was used, what is the sequence of the tendon actions. So a combination of physical information and analytical information all within a single model. Now, following the workflow. Done. I need now my design documentation in the form of reports, in the form of detailing, in the form of plans. So let's compute quantities, for example. So we know what we place. So we know that we have concrete, that we have steel, but not only that. Remember that we are connecting with the ground, so I can define the parameters to identify for me the excavation quantities needed for every single pier. And that's what I have. And this excavation report will become part of the overall quantities reports of the bridge. As we define a material library, and also we can add certain cost to it. So as we want to issue a quantities report in any type of bridge, software will calculate what I need and desegregate the quantities as much as I need it. And then I can make that decision if concrete or steel, segmental or pre-stressed girders. Keep going with the design documentation. Now we need rebar detailing, rebar in 3D. So by the use of ProConcrete, we identify that, yeah, this is a pier, this is a column, this is a footing, and annotate it through that all in 3D. And then not only just one footing, I can just copy the design to all the other ones, create templates and annotate fairly quick, model fairly quick, all the rebars in 3D. Accurate detailing, considering the bar bending radiuses, the splice length that I need to apply to all the elements of my bridge. This rebar as well could be defined by the standards of the country, right? And even identify even the stock length that I can find on every rebar, so the software will just apply the proper splices that I need to. So as you can see, the physical model is also used for detailing as well. And then keep going with the process. Now, what would be the next step? The columns as well. So tools to annotate the columns. So it recognizes from the model that this is not a rectangular column, but actually that's a circular column. and you can define the bar arrangement that it needs with the ties, could be spiral, could be circular, that it needs to be applied for that particular structure. So I can fully detail my bridge in 3D as well. And by the use of reference files in Bentley, all these elements doesn't need to be annotated on the single model. These elements could be referenced as many times as you need it, so we can distribute the work into multiple professionals handling each one, maybe a structure. So this is not the job of a single professional set, it could be subdivided. Then, what is the next step on that reports? Not only the model, but on the rebars, we can just calculate the quantities of rebar that I need, identify by my standard, identify the format that I want to use for reporting them. A format that it comes with the software, or a software that you can just create on your own and accommodate to your particular country standards. Now continue with the workflow of that OpenBridge Designer. So we need to produce the final plans that incorporate rebar, the final plans that incorporate the actual quantities. So we provide the tools in OpenBridge Designer to actually generate 2D sheets. 2D sheets that are referenced to the model. So if any changes into the model, the plan sheet will change. So there is no need of manual drafting anymore, as the drawings are just an extraction, a dynamic extraction of the 3D model. At whatever scale you need it, English or metric, you can set it up how you want to annotate it from the get-go, so all this information is saved. So when you cut, for example, a pier sheet, right, these plans production elements knows what to extract, what views to extract, what frame to use. So it's more or less an automated process to generate a sheet. And also at whatever scale I need to define, architectural scale, English scales, metric scales, not only for the annotation of the text, but as well for the structure itself. And it will just compose the sheet automatically for us. But then, as the plans are done, now we complete the workflow by sending all of that information to construction. So the model that we create is also prepared to receive information that is not particularly related to design. What about if I want to enter into my model information about construction, information about inspection dates, specifications, as I said, information that is not part of design, but through the use of Bentley item types, we can add this information that is not particular on design, but at the same time becomes part of my model. It's the same model being enriched at every phase, being enriched with more and more information that will come from the software itself, like for example on analytical information, but information that again pertains only maybe to our practice. And that information becomes part of the model itself, part of the element itself, and information that I can also report on. I can create my own templates of information, right? And create that, use it and reuse it in as many structures as I need it, and that information becomes part of the model and is fully customizable as well. Then, continuing with the construction workflow, all that information, just to close that circle, all that information, I don't need to have my desktop on the field, because all that information that I can create it could be sent through an iModel, and that information could be loaded into Bentley Navigator, so I can see all my information, all construction and design information right on a tablet. And not just seeing the graphics, but all the information pertaining to the design. All information that was added after the design, like specification sheets, at the detail that I was created on my desktop applications, but now I can have it literally at my fingertips, that information. So not only I can see the graphical element, but as well the specifications used, all the information that I need. And that is the complete workflow, that an integrated workflow done in a single application, OpenBridge Designer, that it goes from the creation of a 3D physical model, transfer these back and forth to analytical, perform the analytical calculations. That information is sent back to the physical model, and from that is when we create all our design documentation and as well enhance the 3D model with more information so it can be sent to construction. Then after that, the construction operations start, inspections, load rating, routing, permitting. So we move from the office to the field using OpenBridge Designer.